Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off in lesson 1 of vectors. So meaning today's lesson will be lesson 2. Okay, so we'll be looking at how to find, the unit direction was vectors. How to find the unit direction vectors. Okay, you can see units, you can see direction. Okay, and anytime you are talking of what a unit direction vector, it means you are looking for a particular vector, okay, in a particular direction, okay, whose magnitude will be 1. So unit direction vector. So your direction vector should have a magnitude of 1. Other than that, it cannot be called a unit what vector. It is still a unit vector, only that we have unit direction vector. So a unit vector in the direction, okay, of what? A certain vector. Okay, and here we have, if A is a vector, then the unit vector in the direction of A is denoted by A cap, okay, A cap or A with a swag, and is defined by, okay, so A cap will always be equal to the vector itself over the magnitude of the vector. As simple as that. You just need to know this. And I have here that direction vector is any vector used to specify the direction of another vector. Okay, that's all. So direction vectors are basically used to specify the direction of another vector. As simple as that. So let's go and see if how best we can make use of this concept in solving the following question. So work example 1. Find the unit vector in the direction of the following vectors. So here you have vector A, okay, in the special notation from position vector, a free vector, position vector. Okay, so let's see how best to work it out. The way you present your solution is very, very key. Okay, all right. So let's look at how best we can present our solution. Okay, here. Okay, so at this point, let's see. The first thing that we write, solution, and we are finding the unit vector. You underline in the direction of another vector. Okay, so questions are not met because we want you to also number your solution. So the major question number is A. 1, and I come to my minor question number, which is A. So A, I've been given the vector A to be equal to, the vector A, okay, is in the column form. Okay, so take note. Because your given vector is in the column form, it means any vector that you are asked to find must also be in the column form. So in this case, you are asked to find a unit vector. Okay, so what you are looking for is also a vector. And that vector must take the form of what? The vector that you have here, which is what? The column form. So in this case, what do? I need to find the unit vector in the direction of this vector A. So it means my unit vector, I'm looking for the unit vector of A. So that will give me A cap. So A to the cap, but I know A to the cap is equal to A, okay. So that's the vector A over the vector A magnitude. Okay, so in this case, what I need to find be the magnitude of what of A. So I can come and write, okay, A magnitude. Okay, I know it's equal to, okay, root of, you know how to find the magnitude of a vector. Your S component squared, so 0 squared. Okay, plus your Y component, which is -2 squared. My professors, are you following?
Yes, please.
Okay, which will give us root of, okay, 0 squared is 0, who right? And this will give us 4. Okay, so that's going to give us 2. And it's magnitude, so don't forget to attach it. Is my point well made?
Yes,
Okay,
please.
ordinarily you can see in books, okay, they will do the two together. They will substitute the vector itself. And okay, however, I will discourage you to from doing that. Okay, because anytime you are working on the denominator, which is finding the magnitude, you have to write the numerator as well. So always take it out, go and find the magnitude, and you come and substitute. Your work will be easy and you write less. So therefore, I will write, okay, A, so that, okay, cap, magnitude of A. Okay, sorry, the unit vector of A will be given by A itself, which is what? 0, -2. all over what? 2. Okay, and we know how to do this. Okay, so this would be 0 over 2, which is 0. Okay, negative 2 over 2, which will give us what? Negative 1. Okay, so this is how far you can go. So you can see that your unit vector, okay, or your vector that you are asked to find here also is in what? The column, because the vector itself, okay, is in the column form. Is my point well made?
Yes, please.
Okay, so you can see that this vector, okay, the direction vector that you are given here, this is a direction vector. The direction vector here is not a unit vector. After going through this transforming it, it ended up being a unit vector. A unit vector in the sense that if you find the magnitude of this vector, you get 1. So let's try and see. However, if you do the right thing, it is not your business to verify. It will always be so. And because it's the first example, I just want us to confirm. So the vector, the magnitude of the vector that we have, they will give us 0 squared, okay, plus what? Minus 1 squared, which obviously you know will give us what? Okay, root of what? 1. Okay, which is equal to what? 1. So indeed, the vector that we have there is a unit vector. Only there is a unit vector in the direction of this particular vector. So we call it a unit direction vector. Is my point well made? Hello, is my point well made?
Yes,
Okay,
please.
all right. Today you are not
Yes,
responding
please.
quickly. So now I will skip the B. Okay, then we'll go and look at what the C, which, okay, is in the ing or the Cartesian form. Okay, so quickly C. Again, the extracts. Okay, what are we giving? We've been given, I should have written given here, but it's not necessary. You can choose to ignore, but let me be consistent anytime I'm extracting, okay, an information that I will need. So given the vector PQ, and it's a free vector, okay, which is in the Cartesian form. So 3i tilde minus what? J tilde. So because your vector PQ is in the Cartesian form, each unit vector, okay, unless otherwise stated, must also be left in the Cartesian what form. So if you want to, you deem it convenient to change from Cartesian to column, which I have advised you not to do. Okay, if you still want to do that, okay, after working with the column, go back towards the Cartesian if you cherish marks. Okay, so in this case, this is what we are going to do. So I'm going to write parts. I know that my vector, I'm finding this is the direction vector. So I'm finding the unit direction vector. So I will write my vector PQ, okay, and give it a cap, put a cap on it. It's the cap that will bring out the fact that we are dealing with a unit direction vector. Is my point well made? Okay, and that will be equal to the vector PQ itself all over the magnitude of the vector, because that is the definition, okay, for the unit vector. And please, anytime you write your vectors in the free, okay, form or using 2 points, make sure you don't forget to indicate the arrows, okay, because it will be the arrows, okay, that will bring out the fact that you are dealing with vectors. So again, we'll go and find the magnitude of the vector PQ, then come and substitute. So what do we write? We are going to have PQ, vector PQ magnitude, okay, will be equal to root of, okay, so 3 squared, okay, plus minus 1 squared. Do you agree? Because it will always be x, okay, squared, then the y, because this is xi, okay, plus yj. So your y will be minus 1. Okay, so in effect, we are going to get, as you write, okay, move on to your next line, you introduce your equal to, which ordinary maybe would have been here. Bring it close to the margin. So in this case, I will get root of 9 plus what? 1, which will give me root of what? 10. Is my point well made? But don't forget to add what? Your units. Hello, my professors, are you following?
Yes, please.
Okay, very good. So at this point, he can now either write implies or therefore. If you write implies and go and carry out your substitution into the relation or the formula that you've stated here, you have to draw your conclusion. So I want to be smart. So my conclusion, therefore, the unit vector of what? The direction vector PQ, okay, will be equal to, we said it will be the vector PQ, which came in the Cartesian form. So I substitute 3I tilde minus what? J, okay, tilde, all over the magnitude of my vector PQ, which is what? Root of 10. All correct. Okay, however, in terms of the Cartesian, okay, your I and the J terms, okay, must be explicit. Okay, you usually don't put them together. But here is the case, you have a fraction with a z in the denominator, and you were told when you were taking through z that you don't conclude with a fraction containing a z in the denominator. Okay, so you know this calls for rationalization. Someone can split before rationalizing. Okay, meaning someone can write 3 over root of 10I minus 1 over root of 10J, then rationalize. But I am going to rationalize before splitting. So in this case, I'm going to write this will be equal to, okay, 3I, okay, minus J, so that, don't forget your tildes, all over root of 10. I'm rationalizing, so it will be times root of 10 over root of 10. Is my point well made? Okay, so in effect, we are going to get this. It will be, okay, the denominator will now come and give us what? 10. Okay, so indirectly, we are going to get root of 10, okay, over 10, okay, into 3I, okay, tilde minus J tilde. Is my point well made? Is my point well made? However, remember I said, okay, you have to split them. You don't write. So it is going to give me, I multiply this one and this. So that will give me 3 root of 10, okay, over 10 I. So that 10 minus what? Root of 10 over 10 J tilde. So this becomes my final answer. Should I come again or my point is well made? Hello, is my point well made? My professors, are you there?
Yes, please.
Okay, all right. So this will be it in terms of, so with that, you should be able to do the B and the D. Okay, however, okay, we are going to solve more questions anyway. So let's look at our next set of questions, okay, which will be quite different from, not entirely different. So, okay, so now what do we have? Okay, question 2. The position vectors of P and Q are, so these are the vectors of these points. So when you are extracting, you extract it in the vector form, not in the point form. Okay, then find the unit, okay, vector in the direction of PQ. Okay, the unit vector in the direction of PQ. So now let's see how best we can present our solution, okay, for this particular one. And please be very attentive. Okay, you see the difference between this one and the first set of questions that, okay, we saw. So solution, okay, is what, so you are looking for a unit vector in the direction of what you have there. Okay, so now what do we have? We are going to write the question number after writing solution. So major question number is 2. Okay, the minor question number is A. So we need to extract. So I'm going to extract giving, okay, here I won't write giving P, capital P is equal to that. And then if immediately you write that, you are saying that the P here is not a vector. A point is equal to a vector. No, points are not vectors directly. Only that indirectly you can write them as vectors. So once you are told that these are position vectors of P and Q, and the position vector of the point P is OP or P tilde. The position vector of the point Q is OQ or Q tilde. I will go for P tilde and Q tilde. So I've been given P tilde to be equal to what? 5 I, okay, tilde 10 plus 7, okay, J tilde. And okay, your Q tilde, okay, will be equal to 6I tilde minus what? 3J, okay, tilde. Don't forget your tildes. Okay, so now what do? We are finding the unit vector in the direction of PQ. So in this case, that's what are we supposed to find? The unit vector in the direction of PQ. So PQ cap, we know will be equal to what? The vector PQ itself. Okay, don't forget your arrow, all over the magnitude of the vector PQ. All correct. Hello, is my point well made?
Yes, please.
Okay, very good. So at this point, you ask yourself, okay, do I have PQ that I can substitute, or I can go and find its magnitude directly? No, you are not giving PQ, directly, for you to substitute and even go and find the magnitude. Okay, so unlike the previous one where the vectors, the direction vectors, okay, that we're supposed to find the unit vector form of it, were directly given. Here, it is not directly given. So you have to go and find your vector PQ before you can use it. So in this case, I know that, okay, and you should equally know that, okay, the vector PQ, remember, will be equal to the position vector of the point Q minus the position vector of the point what? P. So that would be Q tilde minus what? P tilde. With the same as OP minus, sorry, OQ vector minus OP vector. And remember, because I use the special notation from the beginning, that's the more reason why I use the special notations for the position vectors here. Okay, so in this case, I'm going to get, what is my Q? Q is what? 6I tilde, okay, then minus 3J tilde. The whole of that minus your P. P contains two terms, so you have to put it in bracket. So your vector P will be 5, okay, I tilde, then plus 7J tilde. Failure to bring the bracket will be costly. Take note. So this will now, you now come and remove the bracket. Remember from our previous lesson, so 6I tilde minus 3J tilde. If you remove the bracket, we get 5 I tilde, okay, then minus 7J, okay, tilde. So at this point, you come and combine. So 6I minus 5I will give you 1I. I won't write the 1, so I'll write the I tilde. Okay, minus 3J minus 7J, that will give me minus 10J. All correct.
Yes, please.
So now that you know the vector PQ, remember we'll need that of what? Its magnitude as well. So I will come and write, this implies that the magnitude of PQ, okay, will be equal to root of 1 squared, okay, plus what? Okay, 10 squared. So plus minus 10 squared, be careful. Okay, so in this case, we are going to get root of 1 squared, which is 1, and plus 10 squared, which is 100. So we are going to get root of 101. Is that clear? My professors, are you there?
Yes, please.
Okay, so you know all that you are supposed to go and substitute. You know the vector PQ and you know its magnitude. So this said, it's already in its basic form. Okay, if it is not, when you feed your calculator with this, okay, to reduce it for you, but avoid, okay, decimals. Take notes. Okay, so at this point, what do? We are going to substitute. So I'll write, okay, therefore, okay, in carrying out my substitution, the unit vector in the direction of what? PQ will be equal to PQ, which is what? Which is minus, sorry, I tilde minus 10J tilde. Okay, all over the magnitude, which is root of 101. Okay, so as you mature, you can move from here to this straight away without showing the multiplication. Okay, so this will give you, what do you call it? Let me do the separation one first. So this will give you, so that you also know that you can use this approach. I, okay, tilde, then minus 10 over root of what? 101, okay, J, okay, tilde. So at this point, you rationalize term-wise. So if you rationalize term-wise, you know you multiply this one by root of 101 over root of 101. So that will give us 101i, okay, over, okay, root, so it will be, sorry, root of 101, forgive me, over 101. Okay, so that. Then minus, this will give you 10 times root of 101 all over 101. Okay, then j to that. It's my point well made. If you like, okay, just feed your calculator with this. 1 over root of 101, it will give you, okay, the coefficient. You write it there, then you attach your I. You come and do same here. If you can't do it mentally. It's my point well made. Okay, Benedicta.
Mr. Hartman, please, the conclusion part, you didn't bring the, as in the unit vector, the symbol.
It's true, it's true. It wasn't intentional. So in fact, this is the vector PQ, and obviously it cannot be this. Okay, so there should be a cap here. Okay, and if you like, okay, fine. Okay, this one squared plus this one square root of that, you get 1. So making this, okay, a unit word vector. Only that it's not a unit vector, that is that pretty. The prettiest of all the unit vectors, okay, will be the general unit vector, which will be in terms of column 0, 1, okay, then 1, 0. Okay, and in terms of the Cartesian, this is j tilde, okay, and this is I tilde. Okay, because it will give you 0, if you want to change to a Cartesian, to give you 0 I tilde and plus 1 j tilde, which is, so this one you can choose not to write, so that will give you, and this will give you 1 I tilde, okay, then plus 0 j tilde. But this will go, so you get the I. So these are the special unit vectors. Okay, yeah, that's pretty. Okay, so yes, please.
Please, I have a question.
Okay, go ahead.
Please, I'm quite confused about, you see, the initial steps, like the vector PQ is equal to Q tilde minus P tilde. I thought it was supposed to be P tilde plus Q tilde.
No. Okay, please take note, because you haven't done the core math vectors. Okay, would have, anytime you have a free vector, anytime, I even said it in one of the assignment that anytime you have a free vector A, okay, in terms of position vectors, it will always be your terminal point, okay, minus your initial point vector. It will always be like this. So if you have PQ, okay, this will be equal to your OQ, your terminal point vector, position vector minus your initial point position vector. If you have CD, okay, this will be equal to OD vector minus what? What do you call it? OC vector. The other one, remember when we were doing, I think you are getting it confused from the midpoint, okay, theorem. The midpoint, usually we don't write half of what? The vector, let's see if I'm finding the midpoint of the vector AB. Okay, if you write it half of AB, no issues, but you should know that anytime you are dealing with midpoints, okay, this will not be the difference. So usually we don't write this, but I'm saying that if you write it, you should know how to continue. Because frankly speaking, if you write this, then this one in its direct meaning will be equal to half of OB minus OA. Okay, which will be wrong anyway. But anytime you are dealing with what? Midpoint usually you sum. Okay, the x coordinates and the y coordinates, you don't subtract. So that's why it will be plus. You get the point. However, anytime you are moving a free vector to position vectors, it will always be the position vector of your terminal point minus the position vector of your initial point. So get it, okay, once and for all.
Yes, please.
Okay,
I
think it's my problem anyway, because I didn't start from the vectors format. Okay, so no issues, but I've still been able to make the point for you to understand. Okay, so whenever we get there in terms of the format vectors, okay, I will do little or no work there because you understand. Yeah. Okay, so that would be it for this one. So you will try the B. Okay, but later. So you can see that the B is similar to that of what? You are finding a AB vector cap, but you don't know, you've been given the vector A tilde, the vector B tilde. Okay, but you don't know AB, you go and find. So it will be the same approach. So very soon I will ask you, okay, to do that for me. Okay, so let me see the next question, whether I will ask you to do it now. Okay, so let me see. Please do it now and submit. So that's a class exercise. Do it now and submit. Everyone must submit. I'm giving you maximum 5 minutes. Okay, so you will submit the B, okay, later. Quickly, let's look at our next concept. Okay, finding a vector given its magnitude and direction. Remember what we did? We're asked to find the unit, okay, vector in the direction of another vector. So meaning we're finding the unit direction vector. But here, we are going to find the vector itself. Okay, however, if you want to find the vector, okay, given its magnitude and direction, we use this relation that we have here. Okay, all right. Okay, so Bobby has provided, okay, us with the answer, but I will see the approach. I'm not interested in only the answer. Okay, your presentation equally matters. So you give me the presentation pretty soon. All right. Okay, so now take note of the statement that we have here. Every vector, okay, will be equal to the magnitude of the vector. So let me write the vector, okay, in a cell. So that means the magnitude of the vector times the unit direction vector. So times the unit direction vector. We know how to find this. Okay, any, okay, given vector, I mean the direction vector, how to find its unit what vector. We know how to do that. So in this case, you come and find this, okay, because you will be given the direction, but you will not be given the unit direction vector. We know how to find that. Then this will also be given the magnitude. So you just a matter of multiplying the unit direction vector by the magnitude of the vector, then you get the vector that you are looking. So this will be the relation that the D is representing direction. Okay, so D for direction. So direction unit what vector, as simple as that. You can use any letter if you like. Okay, only that you should know what that letter is representing. That's all. Okay, so let's look at the following examples. So given that the vector A has a magnitude of 5 units and it's in the direction of B, okay, so we know how to more or less quote our formula now. Find the A. Okay, so you don't know the vector itself, but you know its magnitude and the direction of that particular vector. But the vector itself, you don't know. We are saying that if you know the direction of the vector as well as its magnitude, we are in the best of positions to find the vector itself by making use of the relation that, okay, you were just introduced to. So quickly, let's go and have a look at what the solutions, okay, together. Okay, so as usual, we are going to get, what do we have? Solution to question 1. Okay, so let's see. I need to find the vector A. So it's A that I'm looking for, but I will extract all the information given. So given the 5 units there, what is it representing? The magnitude of the vector A, is that not it?
Yes, please.
So if I write it this way, am I right or wrong? I've extracted the information in its exact form, is that not it? So this is the masked form of the information there. And okay, you need also your direction vector. Your direction vector B. Okay, tilde is equal to 4I tilde. Don't forget minus 3J tilde. Don't forget your tildes. Okay, even at my age, I don't forget. All right, so now we need to find A. So that we know that your A vector that you are looking for should be equal to the magnitude of the vector A times the unit direction vector. And what is the direction vector? The direction vector is B, is that not it? So it will be times B tilde cap. Is that clear? Should I come again or my point is well made, my professors?
His point well made.
Point well made. So
It's
in this
very
relation, what is missing? It's only the B cap. We know this. So we have to go and find the B cap. So you know how to find B cap. You know that B cap, okay, the unit vector of any vector equal to the vector itself over the magnitude of the vector. All correct. Okay, so we need to go and find the magnitude. So B cap, so B magnitude, again, will be equal to root of. Okay, so that gives us what? 4 squared. Okay, then plus minus what? 3, okay, squared. We know how to find the magnitude of vectors. So this will give us root of 16 plus what? Okay, 25. Oh, sorry, plus 9, forgive me. I've jammed it. Okay, I know we are going to get 25. And okay, so let's go for 16 plus. So let me 9. Let me erase that. Okay. So in this case, we are going to get root of, okay, 25, which will give us 5 units. So now this implies that please don't come and write therefore. The B cap is a means to an end. It is the A that you are asked to find, the A tilde. So that is the one that should take the therefore. So here, if you are asked to find the unit vector, then okay, of B, then you can conclude with that. Okay, so in this case, I will use this implies that my B, okay, cap, the unit vector of B will be equal to the B itself, and B came in the Cartesian form. So it means any vector that I'm asked to find. In this case, A should also be in the Cartesian form. So all over, okay, 5. Is my point well made? Okay, so at this point, someone can choose to go and substitute this one directly here or split before, okay, substituting. So I am going to split. So I will split this and write this one as 4 over 5i, so the minus 3 over 5, okay, j, so that. So I will come and write therefore the A that I've been asked to find, it, so that will be equal to, remember we said it would be the magnitude of A, which is what, 5, times, okay, this vector. But because now what you have here is more than a term, you have to put it in brackets, or you can ignore this and bring the brackets as well. So 4 over 5i, so that minus 3 on 5j, so that. So now you remove the brackets. So that gives us what? 5 will cancel this 5. So that will give us 4. Okay, I, so that. Then this 5 will also cancel. So we get minus, okay, 3j, so that. Is my point well made? Hello, is my point well made?
Yes, please.
Okay, very good. So if you don't have any questions at this point, then I will ask you to try the B, okay, later. Now let's go and look at, okay, the next set of questions, so the C and the D. If a vector A has a magnitude of 2 units and is in the direction of this, okay, find the vector. Okay, so here, take note, the vector didn't come with any name. The vector that you are asked to find, unlike the other one, it came with a name. So find the vector A. Yeah, it didn't come with any name. So if you want to name the vector, you can, but you cannot conclude with that name. Take note. All right. Then now, let's see. The direction vector equally didn't come with a name. Okay, so if you want to name it, okay, you can do that just for convenience sake. Okay, we are asked to find a vector. So this is how we deal with this. Because the direction vector is in the column form, it means the vector that you are also asked to find, okay, with that magnitude and is in this direction, must also be in the column form. Remember this. The nature of the vectors in the question will tell you the nature of any vector that you are asked to find. Don't forget this. So I am going to look at the C. Okay, so in this case, I've been given the magnitude of the vector. So let my vector, I'm going to introduce. Okay, so maybe A be equal to the vector. Okay, that I'm looking for. And I will need my direction vector. So I will use D to be equal to the vector, the direction vector that you have here. That is -3, -4. It's just for convenience sake. Is that clear? Hello, are you with me?
Yes, please.
Okay, so I can say that this implies, okay, that my magnitude of A will be equal to the vector is what, 2 units. So I've extracted that information. Okay, what am I looking for? I'm looking for my vector, which I have labeled A, or any other name of your choice, but I use A, will be equal to the magnitude of the vector, that is A magnitude, but times what? The unit direction vector. Now, what is your direction vector? You represented that by D. Okay, D is a vector cap, then, okay, unit direction vector, you give it a cap. So what do we need to find? Okay, the D cap, and that will be it. So in this case, I am going to write, okay, D cap, D to the cap, we know will be equal to the D itself over the magnitude of D. Okay, so in this case, we will have to go and find the magnitude of D. So the magnitude of the vector D, okay, which you know, will be equal to root of what? -3 squared plus what? -4 squared. My professors, are you with me? Okay, so this will be equal to root of what? 9 plus what? 16. Okay, which again will give us root of 25. So in effect, I'm going to get 5, okay, units. But remember, this is only a means to an end. So this implies, okay, I'm going to substitute to find my D cap. I'm doing all this because of the D cap. Okay, so that will give me my vector D, okay, which is what? -3, -4. Okay, all over the magnitude of D, which is what? 5. Okay, so it means I will end up getting my, okay, D cap in terms of column. So that will give me, okay, -3 on 5, because it will be each of the components here divided by 5. It's the same as 1 over 5 times this. Okay, so it will be -3 on 5. Okay, then what? -4, okay, on 5. Okay, so at this point, what do you do? Okay, you go and substitute. So I'm going to have, therefore, okay, now the main business, A, the vector A, okay, will be equal to, okay, I'm writing something, I'll very soon, okay, correct it, if indeed that you see an issue. Will be equal to, what do we have? The magnitude of the vector, which is what? 2. Okay, then times, okay, the unit direction vector, which is -3 on what? 5, then what? -4, okay, on 5. So in effect, we are going to get our result to be -6 on 5, okay, then -8, okay, on 5. Okay, please, is everyone okay? Is my point well made? All right, okay, so do you see anything wrong with my presentation, especially the conclusion? Okay, so take notes. In math, you avoid concluding with what you introduce. You introduce A, so you cannot conclude with A. Okay, you introduce A to make your work, okay, convenient to deal with. So A has served its purpose. So at this point, okay, you cannot write this. You don't know the name of the vector, so just write the vector. Therefore, the vector is equal to that, and that will be it. Don't put or give it that name in your conclusion. So therefore, I can write vector. The vector is equal to that. I guess my point is well made. My professors, are you there? Is my point well made?
Yes, please.
Okay, wonderful. Okay, so then this will be it for this particular. Let's look at this question. Okay, then maybe let me give you a hint. Once it's in red, it's like, sorry, it's in green. It's very likely you'll see it in your test. You write a short test, okay, before you come back. Just it's very likely, but I'm giving you a hint. Okay, so it's the same thing. Okay, P, Q, R, S, but here you are asked to find S. Okay, the vector S with this magnitude and in the direction of this. So you've been given the magnitude of the vector that you are asked to find and its direction, okay, which is in terms of this. So you can choose to represent the whole of this by D. So D will be equal to this. You substitute here, you simplify. And as you do that, you get a particular vector, which will also be in the column form. Then it's like, it's now in your usual form. Okay, then you go and find the vector S, which will be equal to the magnitude of the vector S times the unit direction vector of this. Okay, and that will be it. Okay, so at this point, we can have our water break. When we come back, then we come and look at what the scalar or dot product. Okay, we are doing well. Keep it up. Okay, so you are welcome back from the water break. Okay, so we are now going to look at the product of two vectors. Okay, the product of two vectors. And in terms of what vectors regarding okay, so regarding, forgive me, I got distracted by a message sent by one of you. So now, okay, regarding the product, we have two products. We have the dot product and the cross product. The cross product, okay, we don't do it at your level. Okay, we only do the dot or scalar product. So dot or scalar in the sense that when you dot the vectors, you end up getting your result being a scalar. So the dot product of what two vectors give you not a vector, but what a scalar. You know that when you add a vector, you get a vector. I mean, when you add vectors, you get a vector. When you subtract vectors, you get a vector. When you multiply a vector by a scalar, you get a vector. However, when you multiply two vectors in terms of the dots, okay, you are going to get a scalar, not a vector. So let's look at what we have here. If my first vector, and I've stated a vector in the column form, and my second vector also in the column form, or, okay, the vectors, if they come in the Cartesian form, okay, then the scalar or dot product of A and B denoted by A dot B. So this is the notation. And is defined by, so we have two definitions. The main definition is this. A dot B is equal to multiply your S components, multiply your Y components, then add. Okay, so it means here, the S components and Y components, they will all be values. So when you multiply, you get values, and therefore, if you add the entire result, you get a value, which will be a scalar. So that's the first one definition. The second definition, that is A dot B is equal to the magnitude of A times the magnitude of B cos of theta, where theta is the angle between the two vectors. So in this case, A and what, and B. I will throw more light on it, okay, going forward, don't worry. Okay, we have two definitions. Okay, you can see that the second definition involves the first definition. Okay, very soon you will know. Without the first definition, you wouldn't be able to deal with what the second definition. However, we usually use the second definition when you are asked to find the angle between two vectors. If the question is only looking for the dots of the two vectors without necessarily, okay, looking for the angle, we use the first definition. Immediately you are going to look for the angle, you put the second definition and you use. However, we have to take note of these vital information here. So let's see, note 1, the first note. The two vectors before the dot product will be valid, before your angle that you are looking for, okay, would be correct, would be the exact angle that we are looking for. Okay, take note of this. The two vectors must be directed towards or away from a common point. Okay, you know, I will have vectors. Let's say immediately I have a point. Let me pick a point here. And I have a vector moving towards this point. I have another vector moving towards this point. So it means the two vectors are meeting indirectly. Okay, and an angle will be found between them. So this will be the angle. And that is the angle that we are referring to as theta. But these two vectors moving towards, it will be the same as the two vectors moving away, because by extension, if I extend and I come and indicate the arrow here, if I extend and come and indicate the arrow here, it's not looking, okay, what do you call it? Straight, but you know, I can still make my point. You can see that if I extend this vector and this vector here, you can now see that the arrows are moving away from the common point. Is that not it? And still, it will be this angle. So the angle here and this angle will be the same. So whether they are moving towards or away from that common point, that angle must be the same. Okay, so here, for the rule to be valid, okay, for the definition to be valid, your vectors must move towards a common point. So anytime you are dotting two vectors, okay, in that case, you are finding the angle between them, and you realize that, okay, they are not moving towards a common point or away from a common point, then you have started wrong. Your value in terms of your angle will be wrong. Take note of that. Now let's come to, okay, 2A. Okay, if A dot B, remember we said this will give us a value. So if your value is greater than 0, meaning it's positive, then your angle there is acute. If your A dot B, its value is negative, less than 0, then it means your angle will be obtuse. So you know indirectly, okay, the size of what's the angle, not necessarily the exact size. Okay, the type of angle that you get whenever you dot two vectors. Okay, then if you dot and you get 0, it means your angle is what, 90, a special situation. Okay, and take note of this one as well. Okay, 3, if A and B are parallel, then your theta, your angle will either be 0, 180, or 360 degrees. Okay, take note. Okay, if your angle theta is 0 or 360 degrees, then it means A and B are parallel, all right, but they are in the same direction. So they are parallel and in the same direction. However, if your theta is equal to 180 degrees, then it means your two vectors are parallel, but they are in the opposite direction. So let me see if I can throw a little more light on that. So assuming this is a vector, I have a vector. Okay, I have another vector. So let me put it this way. There is another vector lying on this vector. Okay, let me do it this way. Okay, once the vector is lying on this vector, you know that the angle formed between them is 0. Do you agree? Hello, are you with me? I have two vectors. You are not responding today at all. Okay, so I have another vector here. Okay, so they are moving away from a common point. So this is the point of intersection. Okay, this vector, I can bring it down to come and lie on this. If it comes to lie on this, they will be in the same direction. Okay, but you see that it will be parallel. In that case, the angle between them will be 0. And again, I can rotate this way for it to come and lie on this. In that case, the angle between them will be what? Will be 360. So the 0 and the 360, they will give you, okay, the vectors moving in the same direction. However, if I have a vector here, another vector here, okay, and I keep on moving the vector, okay, and the vector comes here, you see that this will be the arrow of the vector. and the angle here will be 180. So if the angle is 180, you can see that they will be parallel, all right, but what do? You see that, okay, they will be moving in the opposite direction because this is the angle, I mean the direction, this is the direction of the other line. So that explains what you have here, basically. Okay, I guess my point is well made.
Yes.
Okay, so now let's see how best we can make use of what? The concepts that we have here. Okay, so work the example. Find the dot product of the following pairs of vectors. So if you look at the vectors, some of them are in the column form, some are in the Cartesian form, the two friendly forms of what? Vectors. So let's see how to dot. Okay, when your vectors are in the column or the Cartesian. Okay, take note. So because you are just asked to dot, it means we have to use the first definition. We're not asked to find the angle between them. So quickly, let's go and do that and see. Okay, solution to question 1. Okay, please give me some few seconds. Okay, I will be with you. Okay, so now, okay, we need to find the dot product. Okay, so maybe our underline dot product. Okay, so A. What are we giving? Your first vector A tilde, remember, is bold, so it's supposed to be in the column form 0, 4. Okay, and okay, B tilde, okay, also in the column form 1, okay, 2. Okay, so that's what we have here. Okay, at this point, okay, we know how to dot vectors. So in this case, I'll write, but I know that A dot B will be equal to, I'm writing the vectors, okay, but as you mature, this step, you can take it out. So it means my vector this dot what? That vector. Okay, and this will be equal to, remember we said you multiply this, okay, so it will be 0 times 1, then plus, you come and multiply this 4, okay, times 2. Okay, so this will give us 0, you don't write, then what? 8. Okay, so therefore, your A dot B, don't forget your tildes, is equal to 8. Is my point well made? Hello, is my point well made?
Yes, please.
Great. Okay, so we move on to, let me see whether I should do B. Yes, I will do B. Okay, with you, because that is in the Cartesian as well. Okay, so I mean, so let me do one for the Cartesian. So AB, giving AB to be equal to 2I tilde minus what? 3J tilde. And, okay, your other vector is what? Is CD. Okay, that will be equal to, okay, minus 3I, okay, then plus what? J tilde. So in this case, I'll write, okay, I'm going to be smart. Therefore, my AB vector dot my CD vector will be equal to, remember we said it will be the X, you multiply the X value. So the X value of your first vector, okay, X sub 1 times X sub 2. X sub 1 will give us what? So I'm going to get 2 times negative 3, then plus, okay, your Y sub 1, which is negative 3, times what? Your Y sub 2, which is 1. I hope you are following my professors. Okay, so that will give us negative 6, okay, minus what? 3, which gives us what? Negative 9. So I've drawn my conclusion already. Other than that, if you come and write back here, you will now come and draw your conclusion. Take notes. All correct. Okay, so let's do the last one, the C, together. So assuming this is my next page. Okay, because I will need it. Okay, C. What am I giving? Okay, PQ to be equal to also column 2, 5. Okay, and okay, your QR, okay, to be equal to 10, negative, okay, 4. Now I'm dotting, so therefore PQ dot, okay, QR will be equal to, okay, it will be this times this, so 2 times 10 plus what? 5 times negative 4. So that will give us what? 20 minus 20, which is equal to 0. Okay, so these are carefully selected questions to deal with all situations. Okay, thank you very much. Okay, Kobe. All right, so the dot gave us 0. So you can see that we are looking at 3 situations. The first situation, the dot gave us a positive number. Okay, the second one negative, and the third one 0. So let's go and confirm in terms of finding, okay, the angles and see. We know that if the dot is positive, okay, it means the angle will be acute. If it's negative, it will be obtuse. 0, the angle will be 90. So let's go and check out that from, okay, the questions that we have here. So find the angle between the following pairs of vectors. So it's the same vectors that we are going to find the angles between them. But let's see your approach in terms of dealing with the angles. So quickly, solution. And here, what are we supposed to find? We are supposed to find the angles. Okay, the angles between the vectors. So what do we do? Solution to question 2. Okay, question 2a. You extract what you are giving. So what are we giving? The vector A is equal to what? 0, 4. Okay, and the vector B, so that don't forget your tildes because it's bold. 1, what? 2. Okay, is that clear? So now, because you are finding the angle, okay, you quote the definition in terms of the angle. So in this case, I'm going to write but, okay, my A dot B should be equal to the magnitude of A times the magnitude of B, okay, but that's not all, cos what? Theta, where you know theta is the angle between A and B. Okay, theta being the angle between A and B. Take notes. Okay, so it's theta that we are looking for. Okay, but we will not conclude with theta. Take notes. All right. Okay, so now in this, okay, if you there is an unknown here, which is what? The theta. There is also an unknown here, which is what? A dot B. There is an unknown here, A magnitude, B magnitude. Okay, however, once we know A, we can find the magnitude. Same for B. Okay, and we know how to find this, which we have. Okay, so we are going to find all of them, then come and substitute. So I will write, first of all, I will come and find the dots. Okay, so A dot B will be equal to, remember, we said that would give us 0. We've done that already. You could have inferred. But unfortunately, it's not from the same question, so they are not going to infer. So we have to do it again. So 4, okay, 2, which will give us what? A dot B will give us what? 8. Okay, we know we've done that. We need the magnitude of A. So A magnitude also be equal to root of 0 squared, okay, plus 4 squared. Okay, which will give us what? Okay, 4 units. Am I right? Okay, B magnitude will be equal to root of what? 1 squared plus 2 squared. Okay, which will give us what? Root of, okay, 1 plus what? 4, which will give us root of 5, okay, units. Okay, so let me see. Okay, all right, so we'll get there. Thank you very much. Okay, I like that. Okay, so now at this point, we are in a comfortable lead. We are going to, okay, carry out our substitutions. All right, this implies that I cannot draw my conclusions straight away. In certain book, they will make theta the subject. So they will write theta. At this point, they will come and write theta is equal to your angle, will be equal to A dot B over what? The magnitude of A times the magnitude of A, which is correct. You can make, sorry, did I say cos inverse of this, which is true from the statement, but I don't want us to deal with it that way. Let's substitute and do the change of subject. So that's going to give us 8 is equal to the magnitude of A, which gave us what? 4, times the magnitude of what? B, which gave us root of 5. Okay, then cos of what? Theta. Okay, so cos of your angle theta. So in this case, I'm going to get 8 is equal to 4 root of 5 cos of theta. My professors, are you following?
Yes, please.
Okay, very good. Okay, so on that note, okay, I'm going to assume this my next page. So I will draw a line or rule a line there. Otherwise, whatever I write will be regarded as a rough work. Okay, so at this point, we are more than good to go. Okay, so what do we get then? Okay, we are going to have, okay, we will have cos theta is equal to, okay, you, in actual fact, you were supposed to write this again before you divide. Okay, so I have skipped that step. Okay, you should know. So that will give us, okay, if I divide, okay, we are going to get here, or I should write it. Let me write it. Maybe there's a first example so that you know what to do. So I'm going to write my left-hand side first. Sorry, my right-hand side first, because that contains what I'm making the subject. So I'll write 4 root of 5 cos theta again. Remember, is equal to 8 over 4 root of 5 over 4 root of 5. So in this case, we'll get cos theta to be equal to, this will go here, 2 over, okay, root of 5. Don't come and rationalize. You are not concluding with this. So it means here, theta will be equal to cos inverse, okay, of, you've all done trig, I guess. Okay, so of what? 2 on what? Root of 5. So use your calculator. I'm waiting for the value. I'm waiting. Oh, please hurry up. Okay.
26.5.
26.5.
6.
556.
Yes, please.
That's all.
5.
5.
0.
0.
5118.
Your head like mine. You need to approximate. You need to approximate. Okay, so your first approximation will be 4dp. Remember I said this yesterday.
Yes,
So
please.
take it to 4dp for me.
5650.
50. Okay, then remember it's an angle, so don't forget your degrees. You remember I said immediately you approximate if there is a unit attached before you indicate your approximation. So 4dp. Okay, but unfortunately, we don't want to conclude with theta because we're not asked to find theta. The theta is just helpful. So I'll write therefore, okay, I'll conclude with my 4dp because I was not asked to take it to any convenient approximation or required approximation. Degrees is equal to what? The angle. So that's the angle between them. Is my point well made?
Yes, please.
Okay. Not really. Okay, angles. Okay, it depends on the situations. Okay, that you are for angles. Okay, in maths. Okay, the only approximation that we usually tell you, okay, to avoid 4dp will be currency and age. But even with the age, if you conclude with 4dp, won't give you, okay, won't mark you down. Okay, only that conveniently we conclude with what? 1dp and currency 2dp. By angles, no, you can conclude with any dp's. Is that clear? Okay, all right. So great. So this is what we have, okay, for the first one. And you can see, remember we said because the dot gave us a positive result, we knew the size of the angle, not the exact size, but the range. So we knew that the angle would be acute. And you can see that indeed the angle is acute. So if your dot gives you positive, and you go and find the angle and the angle is not acute, then it means there is something wrong. Is my point well made? Okay, very good. All right. So if that was the case, then I think we can move on to the next. Okay, one. Okay, so I won't do the B. With that, you should be able to do the B. Okay, the B and what are B. Only that the B, whatever you have here, is in terms of what? A Cartesian. You still dot. We've done the dots already. Okay, which gave us, I think, -9 or so. Let me go back and check whether I'm right. Yeah, -9, I'm right. Okay, so you will dot. You start the same way. Your presentation will basically be the same thing. Given this, okay, which will be in the Cartesian form, then but A dot B you put because you are looking for the angle, where maybe theta is the angle between A and B. You should know. Okay, then in this case, what do we do? You need your A dot B, so you go and dot, which we have done. Okay, then you come and find the magnitude of A. You know how to find magnitude of any vector in the Cartesian form. So find the magnitude of what? CD as well. Find the magnitude of AB, find the magnitude of CD. So it will be AB vector magnitude, CD vector magnitude. So that's what you write here. So when you are quoting the formula, it will rather be AB vector dot what? CD vector. Okay, will be equal to the magnitude of AB vector, okay, times the magnitude of what? CD vector, okay, then cos of what? Theta. Then you go and find. You know how to find this. You find this, you come and substitute, then you make theta the subject. And I can assure you, you end up getting an obtuse angle. And the one that is 0, you should know, okay, that if your dot is 0 here, okay, if this gives you 0, then you are going to get this side to be what? 0. So it will be 0 if you divide by this. You are going to get what? Okay, 0 as well. So you get cos theta is equal to 0. And you know, okay, usually we make this statement, okay, cos 90. What you are doing is cos 90 because we know that cos 90 is 0. So that's how come your angle will be what? Will be. So cos inverse of what? Of 0 will give you 90 because cos 90 will give you 0. So you end up getting, okay, 0 as well. Is my point well made? So just try. Okay, we know this will give you acute, now obtuse. This will give us 90 degrees. Okay, we verify. Okay, so let's look at question 3. The question is quite different from, okay, we are really on track. Okay, very soon we'll end the class. Okay, so show that the vectors, okay, so are perpendicular. So anytime you read math question and you see show, underline, because your conclusion must be put in a particular way. This is one direction. Whether you like it or not, they should be perpendicular. So this is what we do. Solution. You extract your vector. So first of all, don't forget your number. Okay, giving A, so that is equal to -8I, so that plus was 6J, so that, and your B, so that is equal to 3I, so that, then plus 4, okay, J, so that. Okay, now this is it. You need to state your condition for the two vectors to be perpendicular. You know that if two vectors are perpendicular, then it means the angle formed between them is 90. Is that not it? So don't go and find the size of the angle because there is a condition, okay, to let us know that the size of the angle will be what, 90, meaning the vectors will meet at an angle of 90 being perpendicular. So in this case, you write for, okay, perpendicular, okay, you should know A, your vector dot B should be equal to 0. That's the condition. So if you dot and you get 0, then it means the two vectors are perpendicular. That's all. You don't have any business going to find the size of the angle. Is my point well made? Okay, so now we are going to take the left-hand side. So that's, okay, A dot B, okay, will be equal to, remember, we are going to get -8 times what, 3, then plus what, 6, okay, times 4. Okay, which will be equal to minus 8 times 3 will give us 24 minus 24, then plus what? 24. Okay, obviously this gives us 0. So once the dot is giving you 0, I will draw my conclusion. Therefore, okay, the vector A, so that is perpendicular to the vector B. Okay, and what is the reason? Usually you attach as required because you were asked to show. So you underlining the show will tell you that you need to attach this to your conclusion. Someone can write, therefore, A and B are perpendicular, but you need to attach as required because you were asked to show. Is my point well made? My professors, are you there?
Yes, please.
Okay, so let's move on to the next question. Okay, if this is fine. Okay, so let's look at this. Okay, I will guide you as to what to do. Maybe I will give it to you as an assignment. So you've been given, okay, let's do it together and see. Okay, this topic is critical, so I have to make sure your understanding is perfect. So solution to question 4. The point P, Q, R, okay, and S have position vectors. So what you are given here are position vectors for each of them. So when you are extracting the position vector form, not in the point form, because they came in the vector form. So I will write, okay, given either I write OP, OQ, OR, or OS, but I'm going to use the special notation. So I'm going to use, okay, P tilde is equal to minus 2I tilde plus what? 3J tilde. Okay, comma, Q tilde, my special notation for the position vector OQ. Okay, 3I tilde plus 8J tilde. Okay, comma. Okay, don't extract in column form. Extract in the row form. You will save lines. Okay, you can see that I'm continuing. I only come down when I've exhausted that line. Then I come down. The next one will be R, okay, so that would be equal to, okay, and that will give out the 7I, so that, okay, plus the 6J, so that, and the last vector will be the S, so that, and that will be equal to, okay, 7, okay, I to the minus 4J to the. So at this point, we need to show that PR vector is perpendicular to QS vector. So I can write this 4, so show you underline, don't forget. 4, okay, let me write the vector PR. Okay, the other one too, I could have written the same thing. To be perpendicular to the vector QS. Okay, we know the dot of the two vectors should give us was 0. So PR vector dots, okay, QS vector should be equal to 0. Is my point well made? Okay, here the only difference is that unlike the first one where you knew the vectors that you were dotting directly, here you don't know. So you are supposed to go and find PR vector, QS vector, then you come and dot. So I will come and write, but I'm going to find my QPR vector, and we know that's equal to your position vector of R, your terminal, minus the position vector of your initial. So you go and find that. Is my point well made?
Yes, please.
Okay, so you find out which gives us what? Okay, 7, okay, I to the plus 6J to the, then minus your P. P, you put it in brackets, minus 2I to the, okay, plus 3J to the. So in effect, we are going to get 7I to the plus 6J to the. Remember, come and remove the bracket. So plus 2I to the minus 3J to the. Okay, which gives us, okay, we combine, you get 9I to the, then the J's will give us plus 3J to the. All correct. And your second vector, which is what? QS. Okay, you know, we equally be S tilde minus Q tilde. Daisy, are you there? Of Daisy. Hello, Prof. Daisy, are you following? Okay, all right. So now what do? We go and substitute and simplify. Okay, so this will be equal to what is S? S is 7I tilde minus 4J tilde. Then minus, okay, your Q. And Q is, you put it in brackets, more than a term. So 3I tilde plus 8J tilde. Okay, so which will give us 7I tilde minus 4J tilde, okay, minus 3I, okay, tilde, then minus 8J tilde. So in effect, this gives us what? 7 minus 3, that is 4I. Minus 4 minus, so minus 12J. Okay, so we are in the best of positions to dot. So now I can write, okay, this implies that the dot of P R dot, okay, and what Q S, okay, will be equal to, you know, we are dotting these two vectors. So it will be 9 times 4, okay, plus what? Okay, 3 times minus 12. My professors, are you following? The S coordinates component, I should say, will multiply. Okay, the Y component will multiply, then you add. Okay, so that gives us, okay, let's go. 36 minus 36, am I right? Okay, which gives us what? 0. Okay, so you draw your conclusion. Therefore, okay, the vector PR is perpendicular to the vector QS. Don't forget your as required. Very important. All correct?
Yes, please.
Great. Okay, so on that note, okay, this takes us to our next question. Okay, and this question equally will be yours. Okay, take note of that. This question will be yours. I think this will be the last question. Okay, this one is the core maths, okay, version of what? So this becomes our last, okay, question. So please, okay, this becomes the class assignment. Let me see if you can do this one and submit by 7 o'clock. By 7 o'clock. 10 minutes should be okay for us to look at this. Okay, I want to see whether there is a knot in it, whether you'll be able to untie that knot. Your presentation will be key. Okay, all right. So that ends it for today's lesson. Any concerns? Okay, let me ask whether we are all fine. Okay, so I'm bringing the curtains down. Thank you, okay, for your participation. Though today I wasn't happy about how you contributed. Okay, but nonetheless, once the lesson is successful, okay, we should thank God. God bless us all.